So from section 15.1, we looked at something like this, which you knew right away was what? 5. So if it says simplify, it's going to say simplify. And you know the answer is what? 5. Okay? That was 15.1. So 15.1, you dealt with the radicands being perfect squares. That's basically what you dealt with. Those are perfect squares. You also dealt with perfect cubes. So you also had this in 15.1, the cube root of 8. What's the cube root of 8? 2. 8's a perfect cube. Cube root of 8 is 2. Okay, that was 15.1. 15.2, simplify radicals. So 15.1 was also simplify radicals. 15.2 is also simplify radicals. But in 15.2, you're going to have something like this. Square root of 18, and you want to simplify that. But 18 is not a perfect square. What whole number times itself as 18? There isn't any. Right? But you can simplify the square root of 18. The index is 2, right? So you can look for a perfect square that goes into 18. And you always want to use the largest. What's the largest perfect square that goes into 18? 9. So here's what it's going to do. You're going to write this, and this is your thought process. In your mind, this is what you're saying. Well, that's going to be the square root of 9 times 2, right? Notice one of my factors is a perfect square. That's what you want to do. You want to rewrite the radicand. You want to rewrite the radicand as a product where one of them is a perfect square. You don't want to say 6 times 3. Don't do 6 times 3 because that's not going to help you. Because neither 6 or 3 is what? A perfect square. That's not going to help. Understand? Say we use a perfect square. Now we learned this also. We know that the square root of 9 times 3 means this. Means the square root of 9 times the square root of 2. I said square root of 9 times 3. I meant the square root of 2. So I can rewrite the square root of this product as a product of the square roots. Now what's the square root of 9? 3. Can I simplify the square root of 2? No. So the answer is 3 square root of 2. So that's how you simplify this. That's your answer. All right? 3 square root of 2. Okay, let's look at this one. So this is section 15.2. So that's the problem starts on page 1122. So this is number 2. Remember, the direction says simplify. Simplify. The square root of 44. First of all, is 44 a perfect square? Nope. But is there a perfect square that goes into 44? 4. 4. And besides one's a perfect square that goes into every number. But 4 is the only other one, right? There's no other perfect square that goes into 4. Remember your perfect squares? Your perfect squares are 1. What's the next one? No. 4. No, not even 3. Okay, here's how you find your perfect square, guys. You say 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. What's 1 squared? So 1's a perfect square. What's 2 squared? 4 is a perfect square because what's the square root of 4? 2. What's 3 squared? 9's a perfect square because what's the square root of 9? 3, and so on. What's the next perfect square? 16. Next one? Next one would be 36, and so on. Okay, those are your perfect squares. All right, you got to know what your perfect squares are before you can simplify these. So one goes into every number, so we don't use it to simplify. All right, what's the only other perfect square besides the one that goes into 44? 4. That's what you want to use. You want to use a perfect square. 2 times 22 is not going to help you right away. Use a perfect square. So I can rewrite 44 as 4 times what? Yeah, but I'm going to write it like this first. But you could have written it as square root of 4 times square root of 11. So the next step would say in your mind square root of 4 times what? Square root of 11. In fact, you could skip those. You could skip this step if you want to and say the answer is just what? 2 square root of 11. There's your answer. 2 square root of 11. All right. Number 6. Okay, before we do number 6, all right, so it's going to say simplify. You have the square root of 21. Then we simplify the square root of 21. What perfect square other than 1 goes into 21? 3 is not a perfect square. Huh? None. There is no other perfect square that goes into 21. So the answer is just the square root of 21. That's the answer. Square root of 21 equals the square root of 21. You can't simplify it, right? So that's the answer. Square root of 21. It's itself. You can't go any further with it. 8 square root of 125. Can I simplify the square root of 125? Yes. What perfect square goes into 125? 5. Nope, 5 is not a perfect square. 25. So the square root of 25 times what? 5. And we note that the square root of 25 is what? 5. So what's the answer? 5 square root of 5. Okay. 14. Square root of 75. What perfect square, if any, goes into 75? 25? And that'll be 25 times what? 3? What's the square root of this 25, though? So what's the answer? Square root of 3. All right. Now, you can always check yourself. For example, here's how you would check this, though. You would put this. You're saying this is the answer, right? 5 square root of 3. So you'd say 5 square root of 3. The square root button is right above the x squared. See it? Right above the x squared. And then put 3. You don't need parentheses, although it automatically puts parentheses, so you just close it. And there's your decimal, right? You all agree? So you got to remember that. It's 8.660, let's say. Let's do the square root of 75. Press equal. You get the same thing, right? Okay. So you can always check it like that. Let's look at 12. Let's look at 10. Square root of 90. What perfect square goes into 90? Huh? 9? Square root of 9 times what? 10? What's the square root of 9? So what's the answer? Root square root of 10? Okay. Let's look at this. Square root, write this example, square root of 32. Square root of 32. All right. What perfect square goes into 32? 4. 4 goes into 32. It's always a good idea, though, to use the largest. 16. If you use 16, you save yourself a lot of grief. I'm going to use 16 first, and then I'm going to use the 4. Let's use 16. 16 times what's 32? 2. The square is 16. So what's the answer? 4 square root of 2. What if someone had used 4 instead? 4 is perfect square. Let me write this over. Four times what? 8. What's the square root of 4? You get 2 square root of 8, right? You agree? Mm-hmm. But remember, you got to ask yourself, can I go any further? Yes, because what perfect square goes into 8? 4. So you can go further with that. That's not your answer because there's still a perfect square other than one that goes into the radicand 8. So you have to break it down further. So you can say 2 times the square root of 4 times what? 2. You agree 4 times 2 is 8, right? I'm circling this because I know I can simplify this. What's the square root of 4? 2. So look, guys, this 2 times this, and what's this? No, square root of 4. 2 times the square root of 2, right? So what's the answer? 2 times 2 is 4. So you get 4 square root of 2, just like that here. So you see, it's always easiest to use the largest one. It's always easiest to use the largest one. Okay? All right. Now let's look at this. Okay, listen carefully to this. Square root. Oh, let's do this. It'll be, let's first of all simplify this. I'm writing this example. 6 times the square root of 9. 6 times the square root of 9. What's the square root of 9? 3. So do you agree that's going to be 6 times 3, which is what? 18. So the answer is 18. So 6 square root of 9 is what? 18. Okay? Let's look at this one. Let's suppose you want to simplify negative 5 square root of 24. Negative 5 square root of 24. Is 24 perfect square? Nope, but is there a perfect square that goes into 24? There is. Let's use the large. Well, 1, I shouldn't have said is there a perfect square that goes into 24 because it's 1. But is there a perfect square other than 1 that goes into 24? Yes, 4. And that's the largest. So I'm going to rewrite this and do it in steps. Don't skip too many things. So there's really negative 5 times the square root of what two numbers? 4 times 6. I'm circling the square root of 4 because I know the square root of 4 is exactly what? 2. So what's negative 5 times 2?
10.
Negative 10. So what's the answer? Negative 10 square root of 6. Negative 10 square root of 6. And if you want to check, although you're going to have to remember that decimal part, if you want to check, you're going to say negative 10 square root 6 equal So that's like negative 24.4948 and so on, right? Let's find out what negative 5 square root of 24 is. So negative 5 square root 24, and notice you get the same thing. Okay? Right. Let's look at this. So this is number 26. Number 26 is this. The square root of 100 divided by 49. The square root of 100 divided by 49. Well, you remember when we first started talking about this product here when we said the square root of 3 times 2 means the same thing as the square root of 3 times the square root of 2. Y'all agree? Okay, remember I can write the square root of a product as the product of the square roots. I can do the same thing here, the quotient. I'm dividing, division means quotient. So I can take the square root of this quotient by taking the square root of the numerator divided by what? Square root of the denominator. So this is really the square root of 100 divided by what? Square root of 49. What's the square root of 100? What's the square root of 49? So there's your answer, 10/7. But what if you had this? What if you had something like 24? Suppose in 24 you have this, the square root of 24 divided by 169. Square root of 24 divided by the square root of 169. So you want to rewrite the square root of this fraction as the square root of the numerator divided by the square root of the denominator. So in other words, you want to rewrite this as the square root of 24 divided by the square root of 169. And now let's simplify the numerator if we can. Can we simplify the numerator? Can I simplify the square root of 24? Yes. What perfect square goes into 24? 6 is not a perfect square, but 4 is. So the square root of 24, I'm kind of figuring out right here. The square root of 24 is the square root of 4 times 6, correct? What's the square root of 4? So what is the square root of 24? 2 square root of 6. So that's your numerator. 2 square root of 6. What about the denominator? What's the square root of 169? 13. So you're done. That's your answer. You can't go any further. But see how we broke it down? The square root of the numerator divided by the square root of the denominator? All right. Number 30. Number 30. The square root of 30 divided by 49. Square root of 30 divided by 49. Break it down. Square root of 30 divided by what? Square root of 49, right? Is there a perfect square other than one that goes into 30? No. So the numerator is going to stay what? Square root of 30. Can I simplify the square root of 49? Yep, it's just what? 7. So that's your answer. Square root of 30 divided by 7. It is not difficult. 32. 32. You have negative square root of 84 divided by 121. Break it down first. So that's going to be negative square root of 84 divided by the square root of 121. All right, now let's talk about the numerator. Is there a perfect square besides one that goes in 84? There's an obvious one. 4. but is for the largest. Well, you may not be able to tell right away, but here's what I would do. Let's use 4 for right now. So 84 is 4 times what? 21. And let's talk about 21. Can a perfect square other than 1 go to 21? No. So 4 is the largest. We're good with that one. 4 is the largest. So what's the square root of 4 though? 2. So the numerator becomes 2 what? Square root of 21. But what's the denominator? 11. So there's your answer. That's all you do. Okay? That's all you do. Let's review something from the previous section. Simplify. The square root of 36x squared. The square root of 36x squared. On those 2 worksheets you did, what was the answer to that? 6x. 6x. Okay? All right, now, I'm going to ask you this. So again, this is still review. Square root of x to the 8th. X to the 4th. All right, now, the new stuff. We're almost out of time, but I want to do a couple more before we're done. The square root of, there's a new one, the square root of x to the 9th. Square root of x to the 9th. It's not as easy as the other ones, right? Because the way we did the others, we said the index was what here? 2. 2 goes to 8. 4 times. So that's how we got that 4. Index was what? 2. 2 goes into 2. 1 time. That's where we got x to the first. But 2 does go to 9 evenly. Right? But here's the idea though. What is the largest number less than 9 that 2 goes into? 8. 8. Right? So do y'all agree I can write this as the square root of x to the 8th times x? Because when you multiply like bases, the product rule, that's where the product rule comes in again. When you multiply like bases, you do what? Add exponents. Now I'm going to ask you, if I cover this part up right here, what is the square root of x to the 8th? X to the what? 4th. So the answer is x to the 4th times what? So remember, it's very similar to what we did earlier, but I'm going to ask you what's the square root of x to the 8th? You're going to say what? X to the 4th, and what's left over? The square root of x. That's your answer. X to the 4th, square root of x. It's not difficult, guys. Look at this one. Watch. Square root of x to the 21st. Square root of x to the 21st. You can do a shortcut at some point, but let's actually write in that intermediate step. What's the largest number less than 21 that 2 goes into? 20. So I can write this as square root of x to the 20th times what? X. What's the square root of x to the 20th? So what's the answer? X to the 10th times what? Square root of x. That's all it is. That's all you do. All right. Now remember, our phrase was, what's the largest number less than that exponent that 2 goes into, right? So for some students, it's a little bit more difficult to kind of visualize that. But if all you do is this, 2 goes into 9 how many times? 4, right? 4 whole number times. But what's 4 times 2? 8. But you could also say this. 4 goes to 9 how many times? 4. That's where that 4 comes from. What's the remainder? 1. That's that 1. See it? 2 goes into 21. How many whole number times? 10. There's the 10. What's the remainder? 1. That's it. Let's use a shortcut. Square root of, square root of, square root of, x to the 33rd. 2 goes into 33 how many times? Whole number times? 16. So what's going to be in the outside? X to the 16. What's the remainder? X to the first. Well, 1. So you get x to the first. That's your answer. You see the shortcut? Now, if you want to do the long way, though, here's the long way. You can say, what's the largest whole number less than 33 that 2 goes into? 30. 32, excuse me, 32. So the square root of x to the 32 times x. What's the square root of x to the 32? X to the 16 times the square root of what? X. That's it. That's all that is. All right. Okay, so we're going to talk more about that Thursday. Now, we haven't done this yet, but we still have to talk about rational equations. So I'm kind of waiting until next Thursday to start talking about that, because that's going to be the hard one for some of you, dealing with rational equations. But there's usually one on the final. And in college algebra, you talk about rational equations some more. Okay? All right, but here's what I want you to do. So this is going to be due a week from today. So don't start working until Tuesday night after your test. But here's A7. Remember that we did the first thing?